My name is Danny Macovei. I work for a company called Just Another Framework, or JAF Labs. And today I'm going to be talking about Wasm-Powered dev environments. And I'm really excited to do it because I think they're cool. So what we will cover first is just a little bit about some of the current workflows that people go through when writing software today and what some of the pain points are that are pretty common, and how Wasm can help alleviate some of the pain that we encounter when we write software today via these Wasm-powered dev environments. And then the middle part will be kind of for the nerds, and we'll be diving into the weeds about how we're actually accomplishing the implementation of these Wasm-powered dev environments. And then we'll get to the exciting part where we're actually demonstrating, writing our software in these dev environments and compiling them on the fly. Yeah, you can get a taste for what it's like to use these things. So, firstly, a friend showed me this GIF recently when they were talking about a pull request that was really bothering them, and it just kind of resonated with me at my core. And so basically, you've got like the dad from Malcolm in the Middle trying to change a light bulb, but then like every single tool that he wants to use along the way also doesn't work, and so he has to fix like thing after thing until he ends up trying to fix his car. But yeah, and it's like, what does it look like I'm trying to do? And so this really is kind of the case when you go and you clone a new repo on GitHub. The number of things that you frequently have to do before you can start editing any code, you might realize like, oh, this thing is Dockerized and I don't have Docker Desktop installed, so let me go get that. And then you look at the Docker file and it needs you to put in an API key for some service that you've never heard of before. And so then you have to go figure out what it requires to access one of those. And then maybe you find out that they recently switched from Webpack to Vite, and you have to deal with that, and then there's like a whole bunch of Semver stuff and things with like breaking changes, and all of this is not writing code, which is the thing that you're trying to do. And so what we thought is that these Wasm-powered dev environments might be able to let us focus on the thing that we're actually trying to do. And the other thing that I'd just like to comment on too is like how prohibitive this is for people who are like trying to get into software, right? Like when you're trying to learn a new programming language, that's like a whole set of concepts that are like the syntax that's involved in Python. But then it can be really intimidating when you have to spend the first 3 hours of your development session doing all these things that are not learning how the language actually works, and instead basically dealing with the fact that your house is broken instead of actually changing the light bulb, right? So, yeah. So the way we're doing this is with these Wasm dev environments. What are these Wasm dev environments? Basically, we have this thing that we're calling edit.dev, and we've got like a little conference domain that we'll be showing off later. But in it, there is a text editor, so you actually can author your source code in the browser. But what we're doing that's a little bit unique is we actually have the compiler running in the browser itself. In the example that we'll be demonstrating today, we've actually got like Rust-C compiled to Wasm. So the Rust compiler is able to be invoked by the browser because browsers understand Wasm. And then it's turning the Rust code into more Wasm, and you can then actually run the application that you're authoring all without, like, the whole thing happens inside of the browser. And we're even, for the backend services that we're authoring, we're actually having those interact with the service worker that we've registered, so it'll intercept HTTP requests, and you can even actually have like your backend services running in the browser, which is pretty cool. And there's not really anything that is special about Rust here. It's just it's the compiler that we compiled to Wasm for the demo, but there's no reason that you couldn't do this with any other compiler or even an interpreter, so you could do this with like JavaScript or Python or anything. And then the other thing that's cool about this is that you have a link at the end of the day. So if you've authored some code, you can just say, hey, teammate, I want you to check this out. They don't have to clone anything. They don't have to do anything on their machine. They open it, they see the code, they run it. That's all that they have to do. So the benefits of this, as indicated earlier, is that there is no configuration or installation hassle. You open a link, and there it is. And then this local first, it really lets you do things in a local first way. So actually, I'll have like an example where if we've seen a lot of people using things like SQLite and like DuckDB compiled to Wasm in the browser. So if your persistence layer doesn't actually require that you interact with the network, your HTTP services could just be running, and you could like turn off your Wi-Fi and like work on an airplane, right? So that's also another thing that is pretty cool about this stuff. And then yeah, basically we'd love to have it where here's the code here. I'm gonna like edit it and then send you my link, and you can actually see what the latest changes are. If you don't understand what's going on, you can add debug statements and recompile the code, and it is just live updating as you're editing in your browser. And the reason we built this is because this is how we want to author our code. We're tired of like saying to somebody like, hey, use this branch, and when you use this branch, actually you have to use this other like re-Dockerize things in order to get things to work with this feature, and like use the test environment instead of the product. And all of that is just like, we don't want to spend time thinking about it. We want to just be able to easily access the code. So the way that it works, as I indicated, is we're compiling the Rust compiler to Wasm. We have this rustc.wasm. There was some prior art that we used as a starting point that I can show you guys. I decided to link to this repo because it also has a link to a bunch of the other repos that were used that kind of we used for inspiration. And so a big step that happened was this person here, Whitequark, did a lot of great work in order to make it possible to use LLVM when compiling to Wasm. And then this other person, Bjorn3, has like a fork of the Rust compiler that leverages the work that Whitequark did. And so that was like the first time that I saw the Rust compiler successfully compiled to Wasm and working. And then the maintainer of this repo is this Oligami. And they actually like have a link here that I can just show you guys really quick, where they actually have the same thing that I'm kind of describing here. You can edit Rust code here. You can select what you want your target to be. You could like say that you wanted it to be Wasm, and then you can compile and run this. And it's really cool if you want to like really understand the details of how to compile the Rust compiler to Wasm. Like this repo is like a really good starting point, and it's where we started. There are some things that are worth remarking on about that. And so one of them is that it produces core Wasm modules. And for us, we felt that we needed to leverage the component model in order to make it so that people could do things ergonomically and like have these full stack web applications that I'm describing that they're authoring using these dev environments. And so, yeah, I'll talk more about the component model in the next slides. But then the other thing, too, is that it requires an implementation of WASI P1 threads, which is itself like an interesting, you don't see it used that much. Basically, there's like a very lively discussion going on about the long-term usage of threads in Wasm. P1 threads was like an early thing. You can use it. I don't think that there's an intention to like maintain it long-term, but like at the moment, we needed to use it because Rust-C has to spawn threads. And we do think that we probably can find a way to potentially not need to invoke threads, and that's something we're going to continue to tinker with. But we currently have a WASI P1 threads in JavaScript, and we also used that prior art as inspiration when going to implement our own implementation of WASI P1 threads. And so the component model, really the main thing is that we wanted people to be able to author backend services, and we wanted their code to look pretty similar to the code that they're used to writing. And I do know people who, use a network from core Wasm, but when you're using core Wasm, you've got the whole thing of the only types that there are numbers, and you're manually writing things to an array buffer, and it doesn't look like the code that you usually write, right? And we wanted people to not have to learn things in order to do this. And the standard that is defined in WASI HTTP makes this really easy. There's also a crate called wstud for Rust that I'll be talking about as well that you'll see we're heavily leveraging in the app that we're using. And then, yeah, also, there are all of these, value propositions that people always bring up when it comes to Wasm: the secure sandbox, the portability, when you can run your code in the browser or on the server, polyglot, and all that. But with the component model, you also get composability. And we also happen to have made a Wasm registry called wa.dev, where you can easily take two Wasm components that were created independently of each other and import and export functionality from each other. So we're really excited, too, to leverage the component model and have people be able to use Wasm that's already been used inside of these dev environments. And again, that's only possible with the component model. And so for the process of componentization, there are basically two kind of strategies that compilers are using right now. I'll start off just talking about Rust. Rust has generally been kind of a pioneer in adopting the component model. Basically, whenever there's kind of new stuff available to use in Wasm, Rust usually makes use of it first, and then you see other languages start to do it. So initially, the way that people were creating components is there's this adapter module, and you basically would just compile your code into a core Wasm module, and then with this adapter module, you can provide a WIT file, and then using this project called Wasm Tools, you can just turn that core Wasm module into a component. And initially, Rust was the first one to do that, and then other languages started doing it, and then Rust actually added WASI P2 as a target that it supports in the stable build of the Rust compiler. So actually, right now, you do not need to do the adapter module process manually at all. If you just do --WASI P2 when you do your Rust compilation, it will generate a component. And I think that there's been some work with TinyGo. They might be able to do this too, but for the most part, the other languages are still using the adapter module. The thing is that when you try to use the compiler compiled to Wasm, this Rust C.Wasm, almost 90% of the difficulties stem from getting linking to work between your different binaries and having your dependencies link properly. And so we found that when trying to use the P2 target that is supported out of the box with Rust C.Wasm, we had issues with linking. So what we're doing in the browser is actually compiling things to the P1 target, and then we compiled Wasm tools to Wasm as well. So in the browser, we're actually using Wasm tools to adapt our core Wasm modules into components. And what's nice about this is because other languages, most of them don't have a P2 target out of the box yet, this is what makes it generalizable. The language maintainers do not need to add a component model, do any work to support the component model. You can use Wasm tools so if you compiled the Go compiler to Wasm, you could do the same process without needing to wait for there to be component model support in Go. And then async, I wanted to talk a little bit about that as well. So we're currently using WASI P2. There have been talks at this conference about WASI P3, which is coming up. And people talk about WASI P3 as enabling async. But you will notice in the demo that we're doing, we're using async await. And so I just wanted to point out that even though P3 is all about async await, it's about async await at the boundary of components. So when you're doing composition, whether the exported functionality can be called asynchronously, or whether you can import something and call it asynchronously. But today with P2, WASI-IO enables you to do async await, and this leans heavily on this WStud crate. But basically, there's a pullable object in WASI-IO that you can use, and then because we're executing things in the browser, we're actually using JSPI, which is a kind of experimental web API that it's the JavaScript promise integration for Wasm. And so we're using that. It is currently, in the demo that we're using, it is you can use JSPI as a cross-origin trial. So we have it activated for this domain. So in order to use our demo, you would either have to use Chrome because it's not in all of the browsers yet, or I do believe it is behind a feature flag in Firefox. But basically, we'll see JSPI coming out. There are other things you can use, like Asyncify, but for this demo, we decided to use JSPI. And yeah, so these WASI-IO primitives that let you deal with blocking and non-blocking logic so that you could do things like async await are themselves pretty low level. And not what people are generally used to writing. They're used to writing async await. And so WStud basically kind of has all of the logic for making it so that you can just do async await, and it builds all of that out of the WASI-IO primitives. So if you want to check out that repo, it's also really interesting. And then it also provides a bunch of stuff too for dealing with HTTP requests the way that you're used to. So you can actually have an HTTP request builder, and there's a body method for setting the JSON body, and you can set the HTTP method and query parameters and headers and all that stuff in a way that feels like what you actually are used to doing when you're not thinking about Wasm. And then the final thing that I'll say about how we're doing things is that you can't compile Cargo to Wasm today. And most people who are building their Rust projects are totally doing it with Cargo. But basically, if you're accessing the network from your Wasm, you need to be leveraging WASI HTTP and doing something like what WStud is doing. So probably at some point, some further iteration of something similar to WStud will be able to be added to the request, the HTTP crates that people want. And then you would be able to do that. But that would be a pretty big PR like into Cargo in order to enable that. Also, Cargo is highly parallelized. I was mentioning before that the thread story like is still like live and active and growing. So we're basically like manually doing what Cargo is doing for the actual like demo app that we're building that we're about to show you. We knew what dependencies we were going to be using ahead of time. So like at the moment, you can't use our thing to dynamically add crates unless it's a crate that we've already done a build for. And this is something that we're very eager to work more on and make it so that you can just grab whatever crate you want. But one of the benefits of this that you'll see is that you can cache a dependency in one project, and then as we have support for having multiple projects, once it's cached in the browser, you can reuse it. So you'll see that when we are compiling stuff in the browser, we have these caches, and we're only building the code that is like the source, like the top level, not any of the dependencies, and you can end up with pretty fast compilation times. We'll be doing most of our compilations in like less than 3 seconds because we've already cached all the builds for all the dependencies. And so yeah, we'll talk a little bit about the architecture for the app that we have too. So basically, we're using wstd. It provides a router is maybe weird wording. You have the ability to check what the route is on an inbound HTTP request when you're writing like something that responds to HTTP requests. And so we basically just have a match statement that checks whether the route that is being requested is one of the ones that is handled in the source code that is being compiled to Wasm. And we again have this registered with a service worker that is intercepting all outbound HTTP requests. So it's basically checking, hey, is there logic for this in the Wasm? If there is, let the Wasm handle it, and do that before actually going and accessing the network. And so this is how we accomplish that local first thing. If your handler doesn't need a network, then actually you would be responding to the HTTP request without ever leaving the browser, and the entire thing would be happening client side. And so some of the routes that we have are serving up the front-end code, the HTML and the JavaScript, and then some of the routes that we have are actually like your services that are sending back JSON that you would use to like render information. So with that, I can actually show you guys how it works. So this is our little example that we have deployed for the conference on wasm.io.edit.dev. You guys can hit this. If you do, it won't. Basically, the app that we're using is this like GitHub issue manager. So in order to make it so that you are only able to like add issues as you, we needed to have a way to add a secret. So you would need to add your like GitHub personal access token in this little secret box right here. WASI lets you access these things as environment variables. So I have like a secret in there right now, and we can see that like when I do this, well actually also really quick, let me do like a refresh, and so we'll see it's waiting to compile as it fetches assets, and then it's doing the compilation, and then you can run the component. And so here is actually the application that is defined by the source code that you were just looking at. And so like on the very first page, what it's doing is it's just doing a fetch to the GitHub APIs and using my personal access token and sending back a list of the repositories that like I own on GitHub. And then we can go and we can actually pick an actual like repo, and we can see here is that repo on GitHub, and we are rendering the issues from GitHub in this application. And just so that you can see that these things do actually update in real time, we can like do that. So if we go and look at where I'm defining like your repositories, I can switch that and say Danny's repositories. And then if we go back up, we can see we're doing a fresh compile. If we run the new version of the application, it says Danny's repositories, whereas this is the old version of it that says your repository. So we can just do a fresh compile of the Rust code and then see it updated. And then we can do thank you. And then we can also go to these places where the issues are here, and we can like actually create a new issue. So here is the issue created on stage, and this is my issue body, and when we submit this, we should see that our code is actually interacting with the GitHub API, and here's the issue that I just created using this app. So it's like a non-trivial application. It's actually going and it's like interacting with the network. And then just really quick too, we can see that if we want to, we can like add a comment. This is a cool, and submit that. And then if we come over here, we actually see like the comment being updated there. And so then also, the last thing that I did was I updated the front end, but we could actually totally update the services that are responding to things as well. So actually down here, I'm going to add like a little, sorry, 1 second, tagline, so that like anytime that somebody leaves a comment, it'll let you know that like developer Danny is the one who left the comment, right? So here I am updating that. We see up here we're doing a fresh compile. I run the component again, and now if I go back to that same issue and I add a new comment, there's the one that we saw from before that I just created, and here is a new comment. And when I submit this one, we should see that that tagline was added because the backend service is actually handling that as well, and we just edited the Rust code that is responsible for our backend service. And then the last thing that I'd like to indicate too is like, if you have something like either a mock that you can totally run locally because it doesn't need to access external APIs, or again, if you're doing something like a SQLite or a DuckDB that's been compiled to Wasm, or even like IndexedDB, if you want to be a little bit less fancy. I actually have an example of just like us mocking out the service that shows off all of our repos. So if I copy that code and then I come over to, I think it is this one. Oops. There we go. And I'm just going to paste this code here so that we use the mock instead. And then up here, where we were using this one, we will instead use our local one. So now if we look up here, it's compiling. It's still compiling. It looks like I have an issue somewhere. Oh, I think I missed the S in static when I copied and pasted, which I saw from the errors that were in the console. I don't know if you guys saw that, but that's pretty cool. Also, I'm just going to do this too, so that you guys can see. That's actually the wrong place. If we go here, and I do a debug statement, we can also see that that will get logged in the console when we actually use it. So now we should have a fresh compile. Let's run the component again, and we see instead of actually hitting GitHub, it's using the mock that has like these hard-coded things. And if we come over here, we can actually see that like our debug is here too. So you can totally actually, if your code is not expecting the way that you expect it to be behaving, you can use this dev environment to figure out why. And because this one is not using the network, we can actually turn off our Wi-Fi, and we should still see that as we refresh, it's continuing to respond even to the HTTP services that are being initiated client-side, because we are actually running our HTTP services in the browser, which is pretty cool. So I guess just our last thing that we'll mention is just some of the things that we want to incorporate into this in the future. Clearly, it's a text editor, and lately all the text editors have been trying to do things with AI. So it would be great to have code gen happening here. I think with Wasm, actually, there's an opportunity to try to actually have the AI also happen client-side, which would be pretty exciting and interesting. And then the other thing, too, to like harken back to that GIF that we were talking about at the beginning, AI, people are generally, when they're using AI to help them with writing code, they're using AI to help change the light bulb, right? To just do the code writing part, right? And you see these little like prototypes, and you can like create links and share them with each other. But like actually, I don't know to what extent people are currently scaling those applications that they're using, right? They're kind of like creating little toy projects. And AI is clearly changing pretty rapidly. Who knows how long that'll be the case? But I think that these environments will be helpful for actually turning this thing from a toy into a thing that you can deploy and have happen, rapidly without yeah. And then the other thing too is, deployments. We want to have a deploy button so that when you have these things, you can actually generate a link that people can actually use. I think that this would also be really cool to test with Canary stuff, or to use for test environments and basically interact with your deployments, but then be able to have a local version in your browser that is modifying one of the services in your service mesh. We also want people to be able to write extensions. We are already seeing in a few text editors people leveraging Wasm components to let people write third-party extensions, and then we should have things like Rust Analyzer and code formatters and all of that happening when we're writing our code. And then, of course, it would be really interesting if we got collaborative text editing happening in there as well. And it was like a full-fledged text editor. So these are all things that we're really eager to do in the upcoming weeks. And with that, I think that I have covered everything. Thanks so much for being here today. Yeah. I don't know what time it is, 9:26. I guess I've got like 4 minutes or so for questions if anybody has any. Yes.
Maybe you covered it and I missed it, but what are you actually using for the editor piece itself? Are you looking for something else?
I totally glossed over that. Yeah, so it's just a code mirror, which is a pretty widely used thing to set up text editors in JavaScript. Yeah, and actually, if you hit it, I should mention, and you like try to edit the code, I should mention that we're also using an extra library for, we like Vim. It won't be the default long term, but as of now, if you hit it, you will have to, well, what's cool too is you can actually like access this on mobile too, and you can like run these apps on mobile too. So if you want to edit the source code, you will have to press I before you start editing, because currently Vim is the default, but yeah. Totally, yeah. And then also I mentioned briefly this registry that we also have, wa.dev. So I think we're definitely planning to leverage this where, if you've actually produced a compilation artifact that you think is worthy of making accessible to the public, you could like publish it to wa.dev. And you can see that like over here, we have pages for WASM components where you can see like auto doc rendered stuff for the WASM that you're using. So you could totally, however you want, you could, there's a lot of methods by which you could share your artifacts, and that's totally a thing that would be possible with this.
Is there any way you can import an existing project?
At the moment, so we are using things like Surdy. I guess project means different things. So we are using like external crates currently, right? And we are building those. So we're using Surdy, we're using wstud. You can do that. We haven't set it up to like handle WASM component composition yet, but that would basically, I don't think there'd be much, like there's tools like WAC that you can use for like component composition that I don't think would be very challenging to compile to WASM. And then anything you can compile to WASM, you can run in the browser, right? So yeah, if you can compose components in WASM, then you can do it here. And that's another thing that we're really eager to do in the upcoming weeks. Cool. Unless there's any last ones, I think I'll hop off the stage. Thanks.